Okay, so we're starting box and whisker plots, also called box plots. What box and whisker plots is that they show the variability, which means how much change is there between data, the spread, how spread apart the data is, and the center of your data set. Okay, center meaning middle, and in this case median of your data. And it's always graphed along a number line. So you're gonna have a box plot, and then underneath you have a number line for reference. And we use 5 different values to make box and whisker plots. Just quick, I'm sure you've seen these before. You have a box, you have 2 lines called the whiskers, and again, it's 5 points. So each endpoint for the whisker, each vertical line on the box, and then the last endpoint are all 5 of the points. All 5 of the values that we're using to describe our data. And then underneath the box plot, or sometimes above it or between them, is just a number line. Okay. All right, so the 5 values are called a 5-number summary. Okay. There's 5 of them, obviously. Minimum, you should be familiar with. It's the lowest value in the data set. We're going to skip first quartile and go to median, which again should be a familiar term. It's the middle value in your set. Okay. Now the median has, a special rule. Sometimes there's a middle number, sometimes there's not a middle. So it's the middle value in the set if there's an odd number of values in that set. Okay, so if there's 5, the third one will be in the middle. If there's 10 numbers in your set, there is no middle. It's going to be between 5 and 6. So how you do that is you find the average of the 2 middle numbers. So whichever one's between 5 and 6, 5.5. That's for even number sets, even number of values. And then the maximum, again, should be fairly obvious. The maximum is the highest value in the set. All right, so what about these 2 that we skipped? The first quartile, also called the lower quartile, is the middle number, the middle value, of the lower half of your set. Okay. So it's the first quartile, also called the lower quartile. What's the lower half of the set? Well, it's everything between the minimum and the median. Okay, so that first set, so you split, in the median, you split it in half. The middle of the first half is the first quartile. Then you could guess that the middle of the upper half is the third quartile, also called the upper quartile. Okay, so the middle number of the upper half, of the upper half of the set, and the upper half meaning between the median and the maximum. When you're finding the first quartile and the lower quartile, or the first quartile and the third quartile, you do not include the median. Okay, because if your median might not even be part of the set itself, so you don't include the median. The first quartile and third quartile are often labeled Q1 and Q3. Technically, the minimum is Q0, the median is Q2, and the maximum is Q4, but you rarely see that. Usually we just do min, med, max, and then Q1 and Q3. One thing to note about the quartiles, and this is for all the quartiles, each quartile, as the name suggests, is a quarter of the data set. Okay, a quarter being 25%. So each quartile represents 25% of your data. Oops. Okay, and this is what a box and whisker looks like. You got your number line, you got the min, Q1, median, Q3, max, and a number line down below. And like we said, each part is a quartile. So each whisker is a quartile, meaning 25% of the data. Each box is a quartile, 25% of the data. Which means there's the same number of values in each of these parts, each of the 4 parts. Okay, so 5 numbers make up 4 parts. Each part is 25%. Okay. All right, and one thing we do have to mention about box and whisker plots is the shape. There's different shapes. They all have the same parts. They all have boxes and whiskers, but they can be shaped differently. So this first one is called skewed left. Okay. How do we know it's skewed left? Well, it has a longer left whisker. That's all that means. If you have a longer left whisker, it's skewed to the left. More specifically, though, it means that most of your data, most of the values in your data, are on that right side of the graph. Okay, or the upper side of the graph, because again, it's over a number line. So most of your data is going to be in those upper values. Okay. The second type is symmetric. Okay. As you can see from this picture, you have all the pieces, all the parts, the whiskers and the boxes are all roughly the same length. Now, very rarely you'll see it perfectly symmetric, but again, it'll be obvious if it's skewed left or versus symmetric. It also means that your median is in the middle, which again means more it's in the middle of the value, so it's halfway between the min and the max. Whereas if you notice in skewed left and in this one skewed right, the median is not in the exact middle. Okay. So this last one's skewed right because it has a longer right whisker. And what that means is that most of your values are going to be on that lower end of your number line, the lower values, smaller values, which are to the left of the number line. All right, so looking at this example we had, that right whisker is looking pretty long, which means it is skewed to the right. All right, there are two other values that go along with the box and whisker plots. These are called measures of spread. Okay. Measures of spread means how spread out your data is. First one is the range. Should be familiar with it. Range is the maximum value minus the minimum value. Okay, so the highest value minus the lowest value tells you how spread out your data is. A big range, if you have a high range, with respect to whatever your values are. If you have a big range, that means your values are more spread out. Okay. And again, big is relative to whatever your data represents. The second measure of spread is called the Interquartile Range, often abbreviated as IQR. Interquartile Range is the middle 50% of the data. Okay, it's the box. Okay, so the box is the Interquartile Range. Interquartile Range is the two quartiles subtracted, Q3 minus Q1. Okay. All right, so let's look at this example. Find the 5-number summary. Okay, min and max are obvious. First number is the min, second number is the max. The median, you're going to have to count how many values there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 values. So the 7th value, which is 12, is going to be your median. The lower quartile is going to be halfway between 5 and that 12. Now again, the median does not count. So there's 6 numbers there. Halfway between them would be between 8 and 9. Halfway between 8 and 9 is 8.5. And then same thing on the other side. Halfway between 14 and 14 is 14. Okay. Now again, one thing to notice is that your data, if you're doing this by hand, your data has to be in order, smallest to largest. Okay. Finding the range and the IQR, just for fun, the range min minus max, or max minus min, 20 minus 5 is 15. The IQR, 14 minus 8.5, Q3 minus Q1 is 5.5. All right, and then we'll plot these values. Okay. On our number line, I'm going to start with a 4 and go by ones, but I'm only writing them every other one, just so it doesn't, save time. Put a dot at the min. Put a dot at the max. Change that color. And I'm going to put dots for the median at 12, first quartile 8.5, third quartile 14, and then from here I'll draw my box. Okay. And then connect the box to your whiskers, and you have a nice box plot. All right. Remember that box is the middle 50%. Okay, that's your interquartile range, your IQR. And then each piece, each whisker, each box is 25% of the data. All right, so let's do an example where we're comparing to. This one we're comparing the weights of lawnmowers or something, blowers. Compare median range and interquartile range of the two types. Okay. So we'll just find the median range and IQR for each type. The median on the electric, look in the middle, 6.75. The range of the electric, biggest minus lowest, 9 minus 5, which is 4. And then the IQR, large end of the box minus small end of the box, 1.5. Same thing for gas. The median, the middle value, is 10.5. The range, biggest value minus smallest value, 12.5 minus 7.5 is 5. And the interquartile range, Q3 minus Q1, 11.75 minus 9 is 2.75. All right, well, comparing those, the gas is obviously a lot heavier in all categories. So it has a bigger median, it has a bigger range, it has a bigger interquartile range. Okay, what percent of electric blowers is less than 7.5 pounds for number 2? Okay. Well, 7.5 is there. Less than it, there's 3 parts. Remember that each part is 25%. So that means 75% of the data, of the values, are less than 7.5 pounds. Similar, gasoline bigger than 10.5. There's 2 parts above 10.5. Speeding up, which means it's 50%. Again, each part is 50%. Each part is 25%. Okay. And comparing electric to gasoline, which one's lighter? Okay, it's obvious from the graph, from the plots, that your electric is lighter. Okay, you could say that however you want, explain it however you want. I'm saying that 100% of the electric data is lighter than the lowest 25% of the gas. Okay, because that entire electric plot is lower than the first quartile of the gas. Okay, the gas is also more spread out. It had a bigger range. All right, and that is box and whiskers. It should be, that should be familiar from previous math classes. Nothing too difficult there.